Okay. First, can everybody hear me fine? You may not hear me. Okay. Can everybody see or read the text on the screen? Too small for anybody? Make a little bigger? Okay. Let's find the, how's that? Okay. It can't be 29, you know. You got to make it an even, you know, font size. Okay, so my first question is, who here doesn't like JavaScript? Really? Be honest.
Sometimes. Sometimes too.
Okay. So how many of you feel like, so maybe you don't dislike JavaScript, but you feel like you're like a beginner at JavaScript? Okay, so like half of you maybe. How many of you feel like you kind of know what you're doing? Intermediate to advanced? Okay, so like a quarter or half. Cool. So this was intended to be a deep dive, and that's where I would like it to go. However, I realized as I was doing this that there are certain concepts that just wouldn't really quite make sense if you didn't have some fundamentals. So what I'm going to try to do is go through the fundamentals. I'll try to go through it at a faster pace. And if you guys have questions, ask them. I want this to be interactive. And however far we get is how far we get. And I've talked to Tim a little bit. There's probably enough content where if we had to, we could do a part 2, do deeper dive JavaScript or something. So yeah, don't hesitate to ask, even if it seems like a silly question, because, and here's why. So for those of you that dislike JavaScript, which there was less of you than I expected, I used to hate JavaScript. And it's because I think, or my reasoning is that when you first get in and start doing JavaScript, it works about like Java and C#. You know, it feels the same. There's if statements and there's loops and you got curly braces and it works, you know, for the most part when you write it like that. And then as you start doing slightly more advanced things, everything stops working and it's confusing. And then that's why people turn off and they don't like JavaScript. And I think part of that's just JavaScript is a little bit different than a lot of languages. It's not bad. It's just very different in a lot of ways. So hopefully I'm going to try to go over those things. So just to start off really quickly, so JavaScript is a dynamically typed or a loosely typed language. It is not weakly typed. So when I initialize a variable to, for example, here, foo equals 42, it knows it's a number. It's not just, it doesn't have any, you know, it knows exactly that it's a number. And if I set it to a string, then it changes and it's now a string. So as you can see with my nice cascading here, we're taking the same variable that started off undefined and then was set to a number and then setting it to a string. So JavaScript does just fine with that. So as for the primitive types, really quickly, so you basically have number, string, and Boolean are the three, you know, building blocks, if you will, with the primitive types. But in addition to that, undefined and null are also their own types. So you need to be aware that undefined is different from null, and it's essentially, like you see here, it's the absence. It has not been initialized, basically, is what you can think of that. Undefined is uninitialized. Null is I'm explicitly setting this value to the null pointer, essentially. Is anybody not familiar with pass by value versus pass by reference? Okay, cool. So primitives, the number, the string, the Boolean, undefined, those are all going to be passed by value. Now you do have reference objects. Essentially, actually, you have, I should say, JavaScript also has the concept of objects. Everything in JavaScript is an object, okay? So, and you've probably seen the syntax. You can initialize one. This is called the object literal syntax, where you are just using curly braces and you're setting it, and that creates an object. There's other ways to create them, and there's some slides with that. So objects can be kind of confusing, and the easiest way to unconfuse yourself with that is all an object really is a dictionary, like a C# dictionary, or I think they're called hash sets in Java, or maps in Python. I'm not sure what they are in that, but they're just collections of key value pairs. That's really all they are. There's also a couple other out-of-the-box things that derive from object, if you will. Things like array, date, regular expression, and function. Actually, it's kind of treated special by JavaScript, but function is also an object. So real quick, if I move over to JSBin, I hope you guys can see that. If you can't tell me. So if we run this, and you might not be able to see this, so I'll go over it. So it's just logging the type of foo. So this is demonstrating how the type actually changes. So it starts off, it's undefined. Then it's set to a number. So when it's logged, when you use the type of operator on a variable, then it's going to return as a string the type that it is in JavaScript. So number returns as you would expect the string number. String returns string. Boolean returns Boolean. Object returns object. But where it starts to get weird is array returns object. Date also returns object. Regular expression returns object. And the weirdest one of them all is null. Null returns object if you use the type of operator on a value that's null. The reason that is because the way JavaScript represents types under the hood is they basically assign them integers, and they use 0 for object, but it's because the null pointer also is just represented with zeros. When the type of executes on it, it returns as an object. The only special case that does not is function. So if you do a type of on a function variable, then it's going to return function. And that turns out to be really helpful because you sometimes need to do checks on that to make sure that you can call it with the open close parentheses, as we'll see. Everybody feel like they kind of get what the types are in JavaScript? Okay. So, question? No, someone is itching their face. Okay. This is my peripheral. So, okay. So comparisons. This is probably the first thing where people are working at JavaScript and then it starts not working like they expect and they start hating it. So JavaScript has the concept of triple equals and double equals. Okay. So is anybody here not familiar with the difference at all? Okay. Cool. That's what I was hoping. So what you think of as double equals in languages like C# is basically what triple equals is doing in JavaScript, okay? So what double equals essentially is trying to do is it tries to do some type coercion and try to help you out and figure it out, and it turns out to not help you out. So you basically, just to get this out of the way, the only time that you should use double equals, and even then it's really not a good case, is if you want to check if something is undefined or null, because you can simply say if variable double equals undefined, and that will also return true if it's null. Otherwise you have to write triple equals undefined or triple equals null. Saves you a little bit of typing. Other than that, don't do it, and here's why. Let me see. I think I've got a bin for this one too. Come on. Oh my goodness. All right. That's loading. I don't want to waste time. So I can just go over what these would be. So this one right here, this is going to return true, right? So even though this is a number and this is a string, JavaScript is going to coerce that, and it's going to return true. Now this one, same thing, but with triple equals, that's going to be false. They're not the same type. Where it is going to work is 42 triple equals 42, where they're both numbers. That's going to return true. How about this one? What do you guys think this one's going to be? Object to object. Any guesses? True. Turns out that empty object against empty object is false. So the reason that is because it is comparing for reference types, it's comparing essentially the memory address. So when you type this, when you specify this syntax, it's creating a new object and it's comparing it to another new object. They're two different places in memory, so it treats them as not the same. NaN, I didn't mention that. NaN is a number type, and it basically is how JavaScript represents anything that's not a number. That's what NaN stands for, if you're curious. This one is probably also a weird thing about JavaScript. NaN, triple equals NaN is false. Nothing equals NaN, not even itself, okay? Undefined double equals null is true. Undefined triple equals null is false. So that's, again, an interesting distinction there. This one is probably the best example of why you don't use double equals. Who can guess what this is going to be? I can tell you what I would expect it to be if I saw this in a language, just in general, is I would expect that to be false. It's true. And we'll see why in just a second. Actually, yeah, there's a great image to go with that. So this right here, I can't take credit for this image. There's a Pluralsight video, just to give credit, by Justin Meyer and Alexis Abril. And it's a fantastic video. And they use this image in the video, and it was just such an awesome image that I'm using it here. So this is the algorithm that JavaScript goes through when you call double equals. And it is not very performant. It's very slow, as you can probably imagine. And it does this recursively. So it's essentially going to loop through and do each of these checks, and then it's going to, so a few of these, so actually the best way, let me just step through it here. So let's use our ridiculous case of true double equals this object. Okay, so the first thing it's going to say is, are the types the same? And if they are, it's just going to call triple equals. So in this case, no, we're comparing a Boolean to an object, so the types are not the same, so it's going to move on to the next one. Are they both null or undefined? No, they're not. If they were, then it would return true. So that is a shortcut out of there. If we're comparing a string to a number, then it has this little state machine map down here that it uses to convert the variable to a number. That's not the case for this one, so we move on to the next one. Are we comparing a Boolean to anything? And we are, so we're going to go down to the state machine here, and we're going to, we're going to compare this against here, and we're going to, let's see, which one of this would it pull? This one should give us, I think it would give us a 1. No, I'm sorry. Yeah, so, sorry, brain fart. So it's going to take the Boolean over here, and it's going to convert that to a 1. So once that happens, it's going to go back through and start at the top. So now we've got one double equals our crazy object. And it's going to go down all the way through, and as you can imagine, its types are not the same. They're not both null or undefined. We're not comparing a string to a number. We're no longer comparing a Boolean to anything. So now we hit this last case, which essentially asks, are we comparing an object to a string or a number? And we are. So what it's going to do in that case is it's going to call toString, or it's going to call .valueOf, if either of those return a value. And then it's going to take the result of that, and it's going to start back at the top. So because we've declared this anonymous object here that happens to have a toString method, that happens to return 1 as a string, it's going to call this when it's going through the type coercion, and it's going to start back up at the top. Essentially, in the last loop, you're going to end up with 1 double equals 1 as a string. And we know in that case, that's going to return true. So again, I wanted to go over that algorithm so you had an idea of exactly what it's doing. As a comparison, triple equals, all triple equals is doing is basically saying, are the types the same? If they're not, false. We're done. Is it a primitive value? If it is, then we're going to do a bitwise comparison of the value. If it's not a primitive value, then we're just going to compare the memory addresses. It's extremely quick. Does everyone understand that? Okay. Let's see. Okay. Objects, and I do have a bin for this one. Come on, man, it's going so slow. We'll go over here. So there's a couple ways you can declare an object. These are all the same right here. That's an important thing that you need to understand. So there's this special object literal syntax. There is where you're actually using the new keyword, and there's where you're using object.create. Okay, and in that example, you pass in a prototype that you want it to be based off of, and that's the deep dive stuff that we will get into. So for example, here we're declaring foo, and it has 3 properties, apple, banana, and orange, and they're each equal to the string of what color that fruit is. Same thing here, we've got bar. Bar was created using object.create, and it's using what's called the dot notation. So bar.apple equals red, bar.banana equals yellow, so on and so forth. These two objects are the same. They have the same contents. This one, same thing. So one thing that's important to note here is that with an object, you can call .apple with what's called the dot notation, and it's going to access that property. Or you can use the bracket notation here and pass in, like you would kind of an array, and pass in the property name as a string. You're going to get the same value back. So the important thing to note out of this is that these are all doing essentially the same thing. So now if you run across weird stuff like that in JavaScript, you know what's going on. Jason Barnes. Okay. So arrays. So the reason that I want to demonstrate this is to simplify the fact that everything is an object. So we're declaring foo and using this array literal syntax. Apple, banana, orange. Bar, we're using the new array, and we're passing in arguments of apple, banana, orange. Again, if we were to console.log these, if JSBin wasn't being so slow, then we would see the same results. Now, array comes with the dot length property, and if we call foo.length, bar.length, they're each going to return 3. That's probably expected. Same thing here, if we access the indices, foo at index 0 would return apple as we would expect. All this is pretty normal. Here's where stuff gets crazy. If you do foo at baz equals 42, then, so remember, this is an array. JavaScript is okay with that, though. So this is where another one of those gotchas where JavaScript does not do what we expect it to do, and we get irritated. And the reason is, again, I'll go back to objects are just key value pairs. So if you want to think of what an array is in JavaScript under the hood, it's this. It's an object where the properties are numbers, but just like with an object, we can have a named property as a string. So this is exactly what foo is going to look like under the hood, if you will, in JavaScript. So so then the question kind of comes up, why do we use an array? Why don't we just use an object for it? And the key thing that you get with array is, well, one, you get some out-of-the-box methods like slice, join, things that are for operating on collections. But the big thing is the length property. So it has a length property, as you would expect on an array, tied directly to the numbered indices in the array. So just to point this out, even after we've added foo at baz, when we call foo.length, it is not returning a length of 4. It's going to return a length of 3. In addition, I don't have this up here, but if you were to sort the array, then it's going to sort it by it's going to use the numbers for that. So it kind of has the named indices like that are sort of in their own little world when it comes to an array. But you can put them in there. JavaScript is just fine with that because, again, it's just an object. Okay. This is something interesting about JavaScript that a lot of people don't know, and that is that you actually have properties. Well, they're called property descriptors, but they're properties of your properties, right? So declaring a plain Jane object up here, and oh man, I do need JSBin for this. Come on, JSBin. Perfect. So I'm going to run this here, and I need to show the console. Why are you not? Okay. So there is a method on the object function called getOwnPropertyDescriptor. And what you do is you pass in the instance of the object and the property that you want to get the descriptors of. So we're passing in foo, and we're passing in the string bar. And this is what you're going to get. I don't know if you guys can see that. What it is it's returning an object with 4 properties on it. So you've got, and the properties on there are configurable, enumerable, value, and writable. Okay? So you can actually, for example, you can make it not writable, which is what I do here in the next example. So we're using the object.define property method to redefine the foo, redefine the bar property on the foo object, and we're setting writable to false. And you'll notice now we do a console.log of foo.bar, and we get baz. Then we set foo.bar to bar, and we log it again. We're still getting baz. So it's no longer writable. In addition, there is the enumerable property, which basically determines whether or not that property is going to show up in a for in. So the for in syntax, if you're not familiar with it in JavaScript, basically allows you to loop through the object, essentially properties as keys, if you will, and access them. So you're going to use it with the bracket notation like this. So you can see here that we're looping through it, logging what the property is, and for the first iteration through, it's these two that's returning. So it's returning bar with baz and boom with bang. After that, we're redefining the bar property to no longer be enumerable. So the second time we loop through it, we don't see bar. It's not going to be returned. So that's important if you're building APIs or you're working with stuff and you need to hide something. You don't want them to be able to loop through it and access it like that. Configurable, I don't have that one up here, but configurable actually specifies whether or not you can change these property descriptors. So if configurable was set to false, then you would not be able to change the writable, or you would not be able to change the enumerable. So those are the property descriptors. Objects also have what are called getters and setters, with which if you're familiar with Java or C#, you're going to have that too. So the syntax would be get, let's see, let's call this combined, and say that it's going to return, what are you doing? I don't want you. Okay, I got it, Windows. Thanks. How do I make you go away? Oh, man, okay. So, if we return bar, this dot bar concatenated with this dot boom, and we were to console log foo dot combined, then we would get baz bang. Okay. You can do the same thing with setters. So you could have a setter function as well here that's going to take in a value right here and then can perform some operation on the object. I had no idea JavaScript had those for the longest time when I was working with JavaScript. So those are the fundamentals of objects in JavaScript. The next important fundamental, functions. So when you're writing JavaScript, if you're creating any major, anything sizable, any program with JavaScript, the two things you're going to be using are objects and functions. That's like the bread and butter of writing JavaScript, okay? Functions are what's called first-class citizens in JavaScript, which I kind of hate that term because it doesn't really mean anything unless you make it mean something. And it basically just means that JavaScript can treat a function just like any other piece of data. So it can pass them around, it can return them. So to JavaScript, it looks just like data until you put the open close parentheses after it, and then it's going to invoke it. There are two syntaxes in JavaScript for functions. The first is called a function declaration. That is this syntax. The second is called a function expression. The reason this is important is because of the way JavaScript compiles its code. These are going to get what's called, the term that's typically used is hoisted to the top. So if I declare this function all the way down here, it's going to get pulled up to the top of all my executing code. Same thing with this Apple check function. This, however, that's not going to happen because it's going to hoist up var foo. So if I was the compiler and I was just compiling a script that had this in it, then I'm going to see this. It's going to, not going to be an effective difference, but it's going to pull var foo up and declare it. And then later on is when it will allow it to be set to the function. So if I had had a bunch of code before here that was working with foo, then foo would have been there, but it would have been undefined. So there's a distinction there in how JavaScript treats those. However, they're both called the exact same. So that's how you'd call foo. Whether we declared it like a function expression or we declared it with a function declaration, it's invoked the same. So the important thing to know here, the way you know if it's a function declaration or an expression is basically if function is the first word in the statement, okay? And that's important for something we're going to go over next, which is what's called an IFI. And they are a huge part of a lot of design patterns with JavaScript. So just keep that in mind.
Is it better to use one or the other?
It's more just a it's gonna be rare whenever you are gonna say, ooh, I need to use this one over that one, but typically it just boils down to that specific use case. So there's no overall one that's better, in my opinion.
Seems as if doing it the first way would relieve you of that gotcha.
It kind of,
Declaring it as a variable.
it does a little bit because it's very straightforward. I think there is an important aspect to that, which is when you write code, I think it is important to write it in the style that's going to be most easily interpreted by other people and isn't going to be a potential gotcha. So you could make an argument for that because someone coming in new to JavaScript would see this and they'd be like, what is going on here? We're declaring a variable and setting it to a function. And it does kind of look weird if you're new to JavaScript.
It looks funky, but then if it's kind of like compares like you described and things start going awry, it's obvious that if they to track down, well, that's a problem.
Yeah, and in that scenario, these are probably your safer bet because they're going to be hoisted to the top. So the primary reason that you're going to use these are there's a few use cases, and we'll get to it when we do the iffy, but where you can't do it with the function declaration syntax. You have to do it with the what's called the function expression syntax. And we'll see that in just a second. So the other gotcha, and if you're new to JavaScript and there's one thing that you take out of this presentation, if nothing else, it's this, okay? In a normal language, if I had an if block, I'd say normal language, and I declare a variable inside that if block, is that variable going to be accessible outside the if block? No, it's not. Well, it is in JavaScript, okay? JavaScript has function scope, okay? It does not have block scope. Now, one of the things they did add in ES6 is what's called the let keyword, and that basically is block scope. And Plunker doesn't seem to like it sometimes. Well, it's fine with it, actually. Oh, that was JSBin. So that would have the effect of it no longer being accessible outside of the if block. There is one exception to that case, and that is a catch block. So if you write a try catch in JavaScript, anything you declare in the catch block is only going to be accessible in the catch block. So it's the one special exception to that case. And that's actually how the transpilers, if you have a transpiler for, if your browser doesn't support ES6, but you want to write ES6 code, then the transpiler, like the Google transpiler for that, if it sees a let keyword, that's actually what it's going to transpile it to, is it's going to write a try catch. It's going to try, it's going to throw, so it goes straight into the catch, and then it's going to set the variable in there. So effectively putting it in its own block, which is interesting.
So I may be skipping ahead a little bit, but that kind of leads into my question. So what's the support like for ES6? I mean, it sounds like it probably depends on the JavaScript engine of the browser.
Yeah, it's gotten a lot better. And honestly, I haven't kept up with that very well lately. I think I don't do a lot of Node. Actually, I don't really know Node other than I know JavaScript. But I believe Node.js has a lot better support for ES6, but I couldn't say that for sure. And actually, there are some sites out there where you can, I forget the name of the site, I could look it up, where it basically just gives you a big table of like, this is what you can do in each browser with ES6. Kind of like you have with CSS selectors. If you want to verify what's... Yeah, caniuse.com. Okay. Okay. So function scope. Don't forget. So this is a little more of an elaboration on scope, and this also shows something what's called variable shadowing. So if I declare a global variable, you know what? We need to see the bin for this. Okay. So, script starts off, it's declaring the variable foo, setting it to bar. So that's going to be on what JavaScript calls the global scope, okay? It's accessible anywhere in any other script. It's declaring a function called bar, and then on the first line there, it's redeclaring a variable called foo and setting it to baz. So what happens when the JavaScript compiler goes through this? It hits this line, and it says, hey, I've got a variable called foo. And it hands it to the global scope, and the global scope says, okay, I got it, thanks. Then it goes into the function bar. It says, okay, I'm in a new scope. Give me a new scope for a function bar. And then it hits the line 7, and it says, hey, I've got a variable foo. Do you already have one of those in bar? No, I don't. Okay, well, now you do, and it hands it to it. That happens all the way through. It finds all these var declarations, and it does that with each one. Then when it goes through and executes, it goes in the reverse. And the best analogy I've heard for this is like go fish, okay? So if we're inside this function, and this is the best example because it's nested. If we're inside this function here, baz, on line 11, the compiler is going to see, the execution engine really is going to see this. Bam equals yay. So the first thing it's going to do is it's going to say, hey, baz, do you have a bam variable in your scope? No, it wasn't declared. There was no baz or bam variable declared in baz's scope. So baz is basically going to say, nope, go fish. So it's going to go up to the bar scope. It's going to say, hey, bar, do you have a bam variable? And it's going to say, nope, I don't, go fish. And it's going to go up to the global scope. And this is another gotcha in JavaScript that they really need to fix. And I believe they have with strict mode. Although JSBin does not seem to adhere to it. So when it gets to the global scope and it says, hey, global scope, do you have a variable called BAM? And what we would expect it to say is, no, I don't. But what it does instead is say, yeah, I just created it for you. Here you go. So that's why when we execute baz, let me see here actually. Oh, I didn't call it. I'm sorry. So that's why it's basically scope leakage, okay? And that's why it's a problem, because you have this variable that you referenced essentially and doesn't appear anywhere else except deep inside this function baz, but is going to be accessible, all the way down here if I was to log it. Yep, we get yay. And the reason JavaScript did that, actually there's two things important here to go over. So the first is the reason JavaScript did that is because when they created it, they wanted it to be easy for beginners. So they thought, well, beginners are probably going to forget the var keyword a lot. So we'll just help them out, and if they do that, then we'll go ahead and just make it for them. We'll let them slide. Except they did it not in the current scope, but they just did it in the global scope. That's where they messed up there. Another thing JavaScript does that's important, and this is a bit of a tangent, but it's interesting. So curly braces. In just about every language, curly braces are like this thing that's fought over religiously. Okay, I don't know how many hours have been wasted of people who say, no, I like the curly braces down here. I like my start curly brace down there. It's got to be down there. I'm like that. I want it down there. It's symmetrical with the end curly brace. That's important to me. Okay? Some people, they want it like this. Okay? It's purely a coding style. And people get fired up about it, but it has no effect on the code. The code runs the same, right? And it turns out the best analogy I've heard for this is some countries drive on the right side of the road. Some countries drive on the left side of the road. One's not more safe than the other. One is not more efficient than the other. There's no proof of that. But what's really important is that everyone agrees to do the same thing. Okay? So that's what you need to do with curly braces. Just come up with a convention and agree to it. What's interesting in JavaScript, though, is that it does matter. You do need to put your curly braces on curly braces on the right or not on a new line. What's worse about that is it doesn't complain if you don't do it. okay? And here's the prime example of where this totally bites you, and I promise if it does, you'll spend hours debugging and trying to figure out why your code doesn't do what it does, and then when you figure it out, you'll be very upset with JavaScript. So this statement here, return, and let's say I wanted to return a new object that, okay? So I would expect bar, when it's done running, to return me an object that has a property foo in it. So we're already calling bar, how convenient. So let's just, oh my goodness. Console.log that, all right? And we get back undefined. It's like, why is this undefined? And you step through it, and it gets here. And the problem is when you're debugging it, it gets here to this line, and it kind of is like, I don't know what to make of that. So it just steps over it, and then all of a sudden you're down here, and it's like, oh, it's undefined. And so the reason why is because JavaScript, another thing that they thought they would do for beginners that's helpful is they would, if you didn't put a semicolon, what they wanted to do was make it so that if you forgot a semicolon, they'd let it slide and they just tack it on. So what the compiler does, if it gets to the end of a line and there is no semicolon, then what it does is it says, oh, they might have forgot the semicolon. So it puts a semicolon there, and then it says, is that a valid statement? Like, is it valid JavaScript syntax and grammar? And if it is, and it says, yeah, that's what we want to do. Okay? So that's what's happening here, is it's just calling return. And if you just return from a function returns undefined. So even if you do return and nothing, or if you take this out altogether, it's returning undefined. And that's basically what's happening. So you get this random object declared under it that doesn't do anything. So save yourself from that hell and just declare your curly braces on the right, no matter how painful it is. And it's still painful for me, but I do it.
What's the proper dimension for, so when you were doing the functions before where you say bar foo equals function, with or without the semicolon after the function?
You mean like if I was to do, just make sure, bar foo equals function, and it was, print something. You wondering if I need a semicolon here?
Yeah, well, I know you don't need one, but what's the convention?
So
With or without the semicolon?
I guess it's not really a matter of convention, but there has to be a semicolon there. If there's not, though, JavaScript's just putting it there for you. So that's that scenario where it's trying to help you out. And luckily, it doesn't cause an issue in that scenario. So and if you're wondering, the reason that this does not cause an issue is because when JavaScript sees this and it says, oh, they might have forgot a semicolon, and it puts it there, the next thing it asks is, well, was that valid grammar? Is that valid syntax? And the answer is no. So it says, oh, okay, I'm not going to put it there. So this is okay. So that's why it's very rare. It's only in that return statement, really, that you're going to see that issue. But it will happen. I promise you. So I used to, for a while, I said, well, I'm going to use curly braces on the left like this everywhere else, but if I do a return object, then I'm going to put it on the right. And it didn't work because I still would miss it. I'd forget it, and then I wouldn't catch the issue. I end up debugging on it for hours, and then I'm like, oh, crap, it's that curly brace issue. So again, save yourself from the hell and just put them on the right. Let's see. So we only got about 10 minutes left. All right, I'll try to move quick here. So closures. So this one's a bit confusing to understand here. Don't pay attention to this. This is just a helper function that I was using for JSBin. So we're declaring a function baz, and we're setting it to, okay, now we're at the iffy. Here's our perfect, actually we need a detour. So JavaScript has the concept of, well, it's not really JavaScript, but it's a name that was sort of coined by the industry, which is an IIFE, which is spelled I-I-F-E. And actually a better slide to show you that would be this module here. So I actually pulled this from an existing solution from work. So I needed to create a variable that was going to represent basically the JavaScript API for one of my pages. So side note, it's typically bad to put hard-coded references to DOM fields in your JavaScript API. But in this scenario, that's exactly what it was for interacting with those specific controls. So kind of an exception there. And see, I did it here. I still do it. So what this is doing here, so if you see this function IIFE, and this syntax came about because people said, hey, I want a way to declare a function and then invoke it immediately. That's what IIFE stands for, is immediately invoked function expression. But you can't do, and Beth, this is what I was talking about with, you can't do it with that syntax. You can't do it with this syntax here because I can't just call it like that. So that's the rule that it breaks. So if you were like, I want to declare a function, just execute it immediately. The JavaScript engine will not let you do that. So again, we go back to our question of, well, how does it determine if it's a function expression versus a function declaration? If the function keyword is the first thing in the statement. So they said, well, let's just wrap it in parentheses. And yeah, that works. So you wrap it in parentheses, which is exactly what this is doing here, and declare your function. And then you invoke it, and all is well. So the first thing people ask is, why do I need to do that? What's the point? And that's where you start getting into JavaScript design patterns. So this is called the module design pattern. And what it basically allows me to do is return a variable that's going to represent, basically, I hate using the word class in JavaScript because there really isn't, but what's going to be like a class in another language. So a self-contained entity that may have private variables and has some public API. So in this example here, I'm declaring a DOM variable. It's got a whole bunch of methods on it. An AJAX variable that points to some endpoints that I had. Post, a few things, an actual post function. So these are all, again, if we go back to our rules, we're declaring variables inside of a function. So these variables only exist in this function. So you can think of them as private variables in that sense. We get down to the bottom here, and it's doing a return. And it's returning an object. See, got the curly brace at the end. And on the object are just a bunch of methods, and this is what's going to get exposed, okay? So if you think about this, we have a function. It's immediately invoked, and when it's invoked, it returns this object, okay? And that's basically what you could call your public API, whatever you're returning down here. So the important thing to know about, so first question I usually get from like a beginner would be, well, you've returned this, but all this stuff up here, now it's gone. I mean, you dumped that function out, it's gone, it's in the world. How are these private variables? And that's where the concept of closures comes in. So when you return a function, and in that function it's referencing a variable from a parent scope, the engine detects that, and it knows, okay, I need to maintain that scope even outside of that context. So best example here would be this AJAX variable. So it's declared internally, but down here in one of these methods, here we go, in this exposed function that I have on the public API, it's calling that AJAX variable. So the question is, well, I've returned this whole object. How does it have access to it? It's because JavaScript sees that and it creates what's called a closure around it. That's why we use ifs, okay? Because nobody else can access these private variables in here. So I've essentially created my own little scope. Side note, you should, in my opinion, name your functions, even if they're anonymous, even if they're an iffy, because you no longer you cannot point to it or gain access to that variable internally here if you needed to. Very rare when you need to do that if you didn't name it. And also, it helps with debugging, because if you don't, then all you see is anonymous function, anonymous function, anonymous function in your stack trace, and that's annoying. It doesn't mean anything to you. So if you see a named iffy that's being executed, then you know, oh, okay, I remember that name. I know where that is. So it really actually is very helpful with debugging. I know we really quickly went over this. Does everybody kind of grasp what's going on here? Anybody not or have questions? Okay. I have like 2 minutes, so I don't know. So I don't think we could get into another topic. So I guess my question would be, does anybody have a question that they're dying to ask about JavaScript? And maybe we'll do a part 2 next time. Yeah.
So I noticed at the top of this you have use strict, but there was another example that you have in strict mode. So
Thank you for pointing that. So that's probably why Plunker was not respecting my strict mode string at the top, because it's supposed to be use strict. So that's an error on my part. Oh, actually, yeah, I'm gonna test that too whenever I get done. I'm gonna see if JSBin will respect it. I'm gonna put use strict. Anybody else?
So on those naming conventions for the ifs, is it, in your experience, do you provide some meaningful descriptor and then always end an underscore iffy, or do you?
No.
Is it pretty evident that it's immediately invoked and everything?
So that was just what I did. That was just a personal convention. I put double underscore there so that I know it's not really a typical thing, but and then iffy, just then I at least know what it is. I see it in a stack trace. It's oh well, I know what that is. So anything that will catch your mind, really.
In that module in your return, you like triple bang. That's what it, you have double and triple dots.
Oh, we didn't go over that, did we? Comparisons. All right, we might be able to do that really quickly. So JavaScript has the concept of truthy falsy values, okay? Which that's really what it's called, okay? So basically, all values are considered truthy except false, 0, empty string, null, undefined, and nan, okay? So a lot of times you'll see in JavaScript code, you know, like if you're checking what came back from an AJAX call, and you'll see if and then just checking the variable. But you know that it's not going to be a Boolean. So you're like, well, wait a minute, that's not going to work. If and then some object or some other variable that normally wouldn't be evaluated to in an if. The reason it works is because of this truthy falsy concept. So the double bang, the reason that you would see that is like if I said, let's say I needed to store in a variable, you know, whether or not we had a result. By doing result double bang, it's going to, so the first bang is going to coerce that into the Boolean using that truthy falsy logic, and then the second bang is just going to reverse it. So it's just a mechanism of quickly turning these truthy falsy values into an actual Boolean that you could store or move around with. So that's what, if you see those double bangs or triple bangs before a variable, that's what that is. Important thing too here, with this being what's considered falsy, that means that the number 0 as a string is truthy. It's not falsy. Same thing with the word false as a string. So that's something that kind of catches people up, but they're truthy. I think about a time.
If there's any more questions, take some questions if you have, otherwise we'll just stuff away. Any other questions for Austin?
Yeah, there's one of our attendees here had posted a good question
Okay.
It was, Ben, I don't know if he's here.
I mean, it was what you didn't get to.
Yeah, we didn't get to go too deep into closures. Actually, there is a really good example here. I can try to quickly explain, but so we've declared this, we use this iffy syntax, and it's setting equal to baz at the end of the day, this function. So if I was to just print the result of baz, then all I'm going to see is a function that calls print and increments foo. So by itself, you would think, well, that doesn't have a foo variable, it doesn't have access to one, but it does because it was declared inside of this scope here. It's going to maintain that link, that memory link. So that extends to this scenario here. So let's say I have a function that takes in as a parameter some other function that it needs to execute. And this is an example of that first class citizen thing. So it takes in a function and it's just going to invoke it. But before I invoke it, I'm declaring a variable called foo. So I declare bar foo equals bar, and then I execute whatever function was passed in. Well, down here I'm doing func_runner and passing in baz. So we know that whenever we call baz up here, it worked fine. It would print 0, then 1. We only called it twice, so it would print 0, then 1, because it's incrementing it each time, and it's going to maintain that state in that variable. But the question would be, well, what's it going to do here? Is it going to print bar, or is it going to print 2? And the answer is it prints 2, because this var foo bar is inside of it. Oh, I wish I had a whiteboard. Is inside of the func_runner scope, but what was enclosed for this function here is just this scope, this anonymous scope here in the iffy. And that foo variable is this number here. So even though this is being invoked in here, this function that got returned, it didn't have a closure around func_runner. It doesn't have any access to func_runner when this is created. So it still has access to that. It's a really weird concept to get, but it's really important in JavaScript. JavaScript would be pretty worthless if it didn't have closures.
So it's kind of remembering the local that should have been destroyed, so to speak.
Absolutely. So really the simplest definition of a closure is a function remembering scope that is no longer in on the stack, really. It's no longer, it doesn't have that context anymore, but it still remembers its scope even though it's outside of that scope lexically. So we only got like halfway, which means that maybe we can do a part 2. I know, this pointer, prototypes, there's a lot of stuff we can go over. The deep dive stuff that I'd hoped really to make this presentation about, but I didn't want to leave out this stuff, so.
Any other questions for Austin? All right, thanks a lot.